I'm Patrick McDermott, and this is my Unit 3 mid-unit assignment. So question 1 is describe what happens to the domain and range of a logarithmic function under vertical reflection. Support your explanation with diagrams. And so my original function is right here, it's just y equals log of x. The domain is x's set of elementary real numbers such that x is greater than 0. And the range is y is a set of elementary real numbers. So then I performed a vertical reflection of the function across the x-axis, as you can see here. That is the newly reflected function. And the domain is the same, just being x's set of elementary real numbers, such that x is greater than 0, and range is y is a set of elementary real numbers. So judging from this data, we can determine that no change will occur to the domain and range of a logarithmic function under a vertical reflection. Question 2 asks, describe what will happen to the domain and range of a logarithmic function under both a horizontal and vertical translation. Support your explanation with diagrams. So again, this is my original function, same as before, the domain being the same, and the range being the same as the previous original function. So first, I will be applying a horizontal translation. Horizontal shifts can occur in two separate ways, either a shift to the left or right. I will be performing a horizontal shift left, expressed by a new function being y equals log x, log bracket x plus d. So here is my newly shifted function. The domain is x's set of elementary real numbers such that x is greater than d, and the range is just y as a set of elementary real numbers, and as you can see. So next, I will be vertically shifting the horizontally translated graph by the amount of c units. This new logarithmic function can be stated as y equals log bracket x plus d bracket plus c. So here's my newly shifted function. There's the vertical asymptote, and the domain is the same as before, being x's set of elementary real numbers such that x is greater than d, and the range just being y is a set of elementary real numbers. So judging from the graph, we can clearly conclude that when a logarithmic function undergoes both a horizontal and vertical translation, the domain will be affected. However, the range will not be affected. So question 3 asks, graph the function 1/2 log x minus 4. And also graph the line y equals x on the same grid. So as you can see, I graphed the original function being 1/2 log x minus 4, and I graphed y equals x on the same graph. Question B asks, graph the inverse function by reflecting f of x in the line y of x. That is what I did here. This is the inverse function, and you can see that one of the points that I graphed on my original function, 10, x equals 10 and y equals negative 3.5, is now inversed right here, being negative 3.5 is now the x and the 10 is now the y. Question C says, determine the domain, range, and equation of the asymptote of the inverse function. This is right here. So here it is. The domain is x is a set of elementary real numbers. The range is y is a set of elementary real numbers such that y is greater than 0. And the asymptote is just y equals 0. So 3D, it asks, determine an equation for f for the inverse function. Okay, so here is my original one being f of x equals 1/2 log x minus 4. I've just written it with being y instead of f of x. And then I switched x and y to give me x equals 1/2 log y minus 4. I then moved the 4 over, giving me x plus 4 equals 1/2 log y. I then multiply by 2 to give me 2 to get rid of the 1/2, which gives me 2 bracket x plus 4 equals log y. I then turn log y into its base function, so it is the base function now. And then I moved it to the left side. And then I moved the log base 10y to the right side, giving me, or just the log base 10, sorry, to the right side, giving me y equals 10 2 bracket x plus 4. And that is my final equation, which means f inverse of x equals 10 2 bracket x plus 4. Thank you.